Good afternoon. Let me go back a little bit. I think we skipped several steps here. Okay, back to the front. Hi, everyone. I'm Eunice Guillarda. I am co-founder and GM of Monad Foundation. By way of quick introduction, if you're not familiar, Monad Foundation is the team behind Monad Blockchain. It is a new EVM L1 that just launched on testnet a little bit over a month ago. Actually, I'll give a little preview on how testnet has been going, but if you haven't checked it out yet, I definitely recommend. There's a place to claim some testnet tokens from the faucet, and again, I'll show you that a little bit later. All right, so to get started, since we're talking about AI today, what exactly is happening with AI on-chain? Well, I think we can kind of bucket it up into three primary categories of what we're seeing right now. There's agents, AI agents that are enacting on a user's behalf, making things very easy and simple and efficient for us. There's LLMs, models. Phrasa AI, for example, was an LLM kind of experiment just to see how humans can interact with an LLM to influence decision-making, for example. And then the last piece is data, because without data, without any input or training data, AI is not really able to do much. So all of these three things are either influenced by crypto on-chain today or have an influence on crypto. So I guess putting it in a different way, what agents bring to chain is utility for users. What LLMs bring on chain is logic, or rather, logic is enabled, and lastly, data used for training. Some of the motivations for why AI on chain, because, that's part of the reason for why we want to understand or how we want to understand use cases on chain. Three things again. 3 is a magic number here. Efficiency, opportunity horizon, and it's fun and engaging. For things that are efficient, as we had mentioned before, agents, for example, enacting on behalf of users, making things easy for us, allowing us to go to bed and allowing us to set intents on how to enact on a portfolio, for example, so that we don't need 24/7 coverage, but still have the confidence that my portfolio is going to do just fine, even if there's crazy market movements while I'm sleeping. The opportunity horizon, there's a lot that we can do on chain. There is a lot of data on chain that is not sufficiently captured and utilized. There's certainly an opportunity to make improvements in both small and big ways all at once. Beyond that, data on chain is permissionless. It is, and also anyone is able to contribute to it. So not only is there access to data on chain, there's also access to provide data on chain as well. And then lastly is the fun and engaging piece, which I think is the more exciting aspect of what makes blockchain as fun as it is. There's already a captive audience. We already know that there's a ton of DeFi users in this space, and with AI, it's branching out not just with I don't even know how to say it, DeFi, as well as other types of AI use cases too. So I think I'm spending a little too much time on these slides here. Closing the chasm. AI and crypto are pretty synergistic. The way that AI can help with crypto adoption, so can crypto adoption help with AI. There's synergistic benefits here. So from an AI perspective, how does AI benefit crypto? Well, we talked a lot about bringing on board more efficient, more exciting experiences. So efficient on-chain transactions or seamless transactions enacting on a user's behalf, not having to fumble around with wallet approvals or whatnot. Guided asset management in a similar case, and things that are just fun and interactive. Lastly, there's also the generative aspect of it, where AI can generate NFTs, for example, or AI-enabled prediction markets that can help settle prediction markets live. And then on the other side of things, okay, well, how does crypto benefit AI? There's a couple of very key key traits of blockchain technology that lends itself very well to AI. Immutability is one. So, strict guarantee of data and state on chain. It's a core tenet to blockchain technology. The ledger is immutable. That's why it is as powerful as it is. From a security aspect, a distributed, decentralized, reliable, and trustless network, knowing that I don't have to put all of my marbles in one basket and trust a single entity. And then the accessibility perspective is honestly quite similar here. Permissionless, open access, and verifiable across various data sets. However, not all of these are inherently guaranteed. Immutability, as we had mentioned, is core to the blockchain core tenets. Security and accessibility, however, we're all familiar with the blockchain trilemma. Not all of this is an assumed guarantee. So if it's not a guarantee, what does the landscape look like? All right, so let's take a look here. I put together a very rough matrix of the 3 traits that we just covered, along with some of the possible solutions. We have L1s, like Ethereum, Solana, Monad, and then L2s and rollups as an alternative form of a platform. I'm adding here 2 additional traits as well, scalability and speed, because these are the other 2 attributes that are frequently talked about with the blockchain trilemma, being security, scalability, and speed, and is also important from an AI perspective as well. All right, so from an immutability standpoint, as we had mentioned, it is a core property of blockchain tech. So check, we've got them both. However, for security, L1s offer security. It offers a form of decentralized, trustless network, but that's not always the case with L2s and rollups, especially those with a centralized sequencer. Accessibility is the same thing. And honestly, sometimes not even granted with L1s. L1s oftentimes are permissionless, but sometimes they are permissioned. And on the flip side, however, in lieu of offering scalability and accessibility, sometimes L1s struggle with being efficient about the scalability and the speed aspects of these traits. Now, not all blockchains are created equal, so I am flashing up here Monad and how Monad stacks up. So Monad, as an L1, we're going to just assume all of the properties of immutability, security, and accessibility. But beyond that, there is also a scalability and speed component that the blockchain is able to deliver. Now, I'm sure you're curious about why. What is the exception here? Well, we'll talk about the key optimizations for why Monad is impactful for AI. All right, so here is the Monad stack, so to speak. There's 4 primary optimizations that this blockchain is bringing to market. The first of which is asynchronous execution. Asynchronous execution, and we'll deep dive into all of these in just a bit, will deliver us more efficient computation, in which case will lead to more transactions on chain. For parallelized execution, parallelized execution, this is a more optimized way of resource allocation, and therefore also allowing for a greater number of transactions on chain. MonadDB is a custom-built database, and this custom-built database is specific to the database structure that is required for EVM, which is the Merkle-Patricia tree. In doing so, there's better state storage, data retrieval, reads and writes. And then MonadBFT is the consensus mechanism. The team behind, Category Labs is building the Monad blockchain client, and they actually released a paper just a couple of days ago about the new MonadBFT. And in this new MonadBFT, it is an even more performant version of communication across the network, which allows for greater network scale and reliability. Okay, so again, in summary, scale, and speed. All right, so diving deeper a little bit into asynchronous execution. So most blockchains have interleaved execution and consensus within blocks. The reason why this is inefficient is because consensus is expensive. Consensus is, literally like one node talking to another, and all across the world having to come to agreement. It takes a lot of time. So with Optimus asynchronous execution, it allows for more time for execution, more time for transactions per block. So this here kind of shows, let's just assume like these two, this blue block here is execution, the orange one is consensus, and those two combined are representative of a single block. And so in a traditional case, both things need to happen before the next block and the next block and the next block. And you can see that the time budget for consensus takes up a ton. It's, in Ethereum's case, over 99% of the time is spent on consensus than it is on execution, which is extremely inefficient. So with asynchronous execution, the proposal is to pull out execution from the hot path of block production. So consensus can continue on, and execution can happen separately. We'll talk a little bit more about how this is the case in the next feature as well. So the reason why asynchronous execution is triply powerful is that when you pull out the execution from the hot path of block production, you can actually utilize the full block time here for execution. So instead of just that tiny sliver of time used for execution, now we can use it for the entire time budget allocated to a given block. Parallel execution, now this is kind of where I'm getting into even more speed-ups here. Historically, blockchains have executed serially, which means one transaction after the next, which maintains ordering. However, in parallel execution, we do the same by, but utilize more of the machine's resources, being more efficient with scheduling and also rescheduling conflicts if needed. So really quick here, let's just assume that this is our list of ordered transactions. We're going to zoom into 1, 2, 3, 4, 5 here. In a typical way of serially executing transactions, one would be scheduled before 2, before 3, 4, 5 here. Now, the blocks here kind of indicate the time it takes to execute transactions, since not all transactions require the same level of computation. Some require more, some require less. What is being proposed with parallel execution is to split them up across different resources. So in this example, let's say that we have 3 threads. A lot of our machines today are multi-threaded. Why not use all of those threads? And so here, we've basically allocated transaction 1, 2, 3, 4, 5, 4, 5 accordingly with the resources available at any given time. I'm going to speed through here, but this is also kind of an example of like, well, what happens if there's a conflict? Because the way that this is written is there's a conflict between 3 and 1, where 3 is dependent on 1. So if it needs to be committed specifically in this order. In this case, 1 is fine to be committed because there's no prereqs. 2 is fine because there's nothing that's required prior to it. But 3, however, in optimistic execution, there is a bit of a conflict here. Again, I'm sorry, I only have 2 minutes, so I'm going to breeze through here and kind of show that like this would be re-executed, re-updated, and then happy path. All right, MonadDB is the third optimization. So as I had mentioned, this is a redesign of the database specific for blockchain schematics. This here is an example of what the Merkle-Patricia tree looks like. It's honestly complicated. There's a lot of hashing at every single level. There's like 16 children per level. And it's not super ideal for commoditized hardware, for commoditized databases. So MonadDB solves for that by building it from scratch. And then lastly, MonadBFT, as I mentioned, is a new fast consensus mechanism with linear complexity. This is pretty massive when it comes to communication across like various nodes around the world. Linear complexity is hard. So efficient block propagation with erasure coding. Larger sizes means more data. All right, so all of this basically means that a lot of the monad optimizations are good for AI. 45 seconds here. Okay, so we're going to speed through to testnet. I just wanted to flash this here. So testnet.monad.xyz is where you can go and find information on how to grab some testnet tokens and play around with different applications that are deployed. There's over 200 total projects deployed, and of them, about a little over 20 AI projects right now. This is a permissionless network, which means any project, any AI agent, any AI team can go ahead and publish on-chain to the Monad testnet. And lastly, just for fun, gomonads.com is like a live view of the network. This is not live because it's a screenshot, but if you go to gomonads.com right now, you can actually see live stats and the performance of the Monad testnet on-chain. And that is it. Thank you so much, everyone.